Hi, so I wanted to explain what's meant by doing an integral by completing the square, and you can find examples of this on Khan Academy, but they're done with numbers, and I think you should at least look at it algebraically. So suppose I've done a very general integral here with a, b, c, and d are just some kind of constants, and we have a second grade polynomial in the denominator, and then just something. And we want to integrate it, and we have a hunch, and the hunch we have is that we would like to get it in this form, and then some kind of constant multiplied by it. Why? Because this is a standard integral. It will be the arcus tangens. So how do we get from here to there? Well, a second grade polynomial can be factorized. You know, when you get something like x minus p times x minus q, where p and q are the roots of this polynomial. That is to say, where this will have the value 0. And from there, now I use p and q, which I already used there. From there, you complete the square by, so you create it as x minus something squared, and this might not turn out to be even for this, so you have an extra constant. So p and q are now constants that you will get from b, c, and d. Their values will depend on b, c, and d to get this neatly. You might want to start doing this by dividing everything by b, so you get x squared plus c over b x plus d over b. I mean, c over b and d over b will then be your new constants. You can introduce more constants if you need. Okay, so we have this in this form then. We're getting closer. We have something divided by a square plus a constant. But we want not a constant, we want plus 1. So I break out q from this, or the root of q rather. Because if you have x minus p everything squared plus q, this is the same as q times x minus p squared divided q plus q. And therefore you can put it in a parenthesis and make this into plus 1, which is what we wanted. And since this was supposed to be a square, if I put the square root of q there squared, I can then put it as a general square. So I have x minus p over root q, everything squared, and plus 1. If you want, you can follow this backwards by multiplying q into the parentheses and then simplifying it. Okay, so for some kind of value of p and q, you can get to this, and this sort of strange variable we substitute for u. So u will be x minus p over the root of q, where p and q, as I said, come from completing the square, so they will in turn depend on b, c, and d. And this q and the a you break out to put in front of the integral, so you will have a over q times the integral of 1 over 1 plus u squared du. And please note that the substitutions we have made are linear. So here, for instance, we change an x for an x minus p. That's not going to change the du or dx. And then we divide by the root of q. So basically you will have that du equals dx. You won't mess up anything else in your integral. I understand that there are lots of parts left blank here. I encourage you to try it with numbers instead of general constants, but at one point or another you should get so algebraically confident that you can actually do this manipulation on your own. And yes, it will take lots of steps, probably 1 or 2 A4 sheets of paper. Use lots of brackets and explanations to keep things very clear for yourself. Don't take too large steps at a time so you don't get lost in it. And as I said, on Khan Academy you can see this done with numbers instead of letters. If this step feels strange or unfamiliar, simply look for instructions videos on completing the square, which is a useful technique to know. Good luck!